All right, for the review about finding inverses, if you look at number 29, it says describe the process to find the inverse graphically. So all you got to do is find some points. So we want them in X, Y form, and then switch them. I don't know what it's spelled. Hang on a second. Switch and regraph. So if we have this X, Y point, we literally switch the two numbers. We put it as Y and then X. So I'm going to go over to the graphing section. I'm going to find as many points as I can. So it looks like there's a point here, a point here. So my points for my original, we got -1, 1, -2, 2, -3, 1, and then it looks like -4, -2. So for my new points, for the inverse, I take each of those points and I just switch them. So it's 1, -1. And by the way, I'm not just changing signs. I am literally switching the order of the numbers. So this is 2, -2, 1, -3, and then -2, -4. So we regraph. 1, -1 is here, 2, -2, 1, -3, and then -2, -4. So we get the shape that goes kind of like this. If you want to make sure it's, if you're on the right track, you can also look across this line of symmetry, across Y equals X, and it should be a reflection of itself. 34 is done pretty much the same way. We got dot here, and maybe, I don't know, a dot right here. So for the original points, we're at -6, 1, -2, 5, and what is that? 1, 2, 3. Looks like 3, 7. So then for the inverse, we just switch them. So we're at 1, -6, 5, -2, and then 7, 3. So we regraph 1, -6, 1, -6, right here, 5, -2, 7, 3. So we end up with a graph that goes something like this. Again, want to make sure it's correct. You can look across this line of symmetry, Y equals X, and it should be a reflection. So that's graphing. The next thing we're going to talk about is inverses of equations. So to find the inverse of a function algebraically, you switch the X and the Y. And then you just resolve for Y. So if you look at the problems above, we don't see a Y. Well, we learned in this class that f of x means Y. So the first thing I'm going to do is just kind of switch it out. So we have a Y and an X. Then I'm literally going to switch the X and the Y, and I'm going to let everything else stay where it's at. So this is 2/3 Y now, and then plus 1. Then I'm going to solve for Y. So I'm going to subtract 1 from both sides. X minus 1 equals 2/3 Y. If you want to get rid of any fraction, all you have to do is multiply by the reciprocal, and you have to make sure you do that to the other side. And we want to make sure we do it to the entire side as well. So we need to put that in parentheses. So this cancels for 2, 3 cancels for 3, and we're left with Y equals 3/2 X minus 1. And then if you want, you can change it back to the f of x. So we'll write it as the inverse of f of x equals 3/2 X minus 1. Next problem is done pretty much the same, so I'll switch out the f of x as a y. And we literally just switch the x and the y. Everything else stays the same. We have to isolate those parentheses because the y is inside of it. So first we're going to get rid of the 2 by adding it. So we have x plus 2, y plus 5 to the 3rd power. To get rid of something that's in parentheses to the 3rd power, we just have to cube root it. When you cube root, you have to make sure you put this little 3 here, otherwise it means something totally different. So you have the cube root of x plus 2 equals the cube root and the 3rd power cancel each other. So now you're just left with y plus 5. So to get the y by itself, you subtract 5 from both sides. So you end up with cube root x plus 2 and then minus 5. On the outside, notice this line doesn't cover the 5. It's not supposed to, not on this problem. And I'm going to just go ahead and switch it back to f inverse of x. So that's all you need to know about inverses. Let's see what else we got here. I think we had some stuff about transformations, problem number 35. So when you're doing transformations, what you can do here is you need to just kind of look at where the current graph is. So we need to know what h and k is. It's the starting point of this shape. It's an exponent of 2, so that tells us it's a parabola. We find the h from looking inside these parentheses, and then the k is this guy. Now, the thing that's special about this h, though, is it's always the opposite of the number that's inside the parentheses. So our starting point is 1, 3. So if we're going to write this new graph, we kind of have to just look at where we're at on the x-axis and the y-axis and apply those shifts. So if you just consider the x-axis, we're currently at 1. It says to move right 3. So if I'm already at 1 and I want to go right 3, 1, 2, 3, that puts me at 4. 1, 2, 3. So we're going to use this number to write our equation. And then we're also going to look at the way it's moving vertically. We're currently at 3, and they want us to go down 7. So 1, 2, 3, 4, 5, 6, 7. So if I'm at 3, that's 1, 2, 3. So this is 0 right here. So that makes this negative 4, and we need to use that to write the equation. So if we're going to write this new equation, we can, let's see, what do they want us to call it? They want us to call it g of x. So we're going to say g of x is equal to, we move the graph sideways to the right 5, or actually 3, and that puts us at 4. So on the inside of the parentheses, since it's a positive 4, I'm going to write x minus 4 squared. And then we move it down 7, and that puts us at negative 4, so I put negative 4 here. Then they want us to also reflect it. A reflection happens anytime you put a negative in front. And then they want to stretch by a factor of 4. That also means just put the 4 in front. So that's your new function. Next, determine if the functions are odd, even, or neither. So just in general, if your problem, if you look at all of the exponents, if they're all even exponents, the function is even. If they're all odd exponents, the function is odd. And then if you have a mixture, that just means it's neither. Now, in my class, we actually use numbers to test. So what we do is we pick a number, and I told my class not to use 0 and 1 because sometimes those actually don't work. So we just pick a number, and so a lot of times we'll use 2. So what we'll do is we'll figure out what f of 2 is. So that can all be done in the calculator also. So this is 2 to the 4th power plus 7. It gives us 23. Then the second thing we test is the same exact number, but we change the sign. When you type that all in the calculator, it still gives you 23. So using this number test, if you end up with the same number, that means that it's even. So there's 3 basic scenarios that you kind of have to account for. Either the numbers are going to stay the same, the numbers are going to change signs, or the numbers are just going to be completely different. So again, I'll use the same number test in this one. So I'm going to try f of 2, and then I'm going to try f of negative 2 and see what happens to my numbers. So we have 4 times 2 to the 3rd power plus 8 times 3. So just make sure you plug in both of them. There's going to be two actually I don't know why I put a 3. There's going to be 2 2's in here. So I'm going to change this to a 2 in my calculator. And so when I plug in positive 2, it gives me 48. And I go back into my calculator and I change both 2's to negative 2's, and that ends up giving me negative 48. So the second scenario is when you plug in a number, and then you plug in the same number but change the signs, the results are opposites of each other. Same number, different signs. So that means that the function is odd. And you can also tell, like I said earlier, you can tell just by the exponents. This has a 3, this has a 1. Both exponents are odd, so overall the function is odd. That also works for 36. This has a 4. And even though we don't see an x, it's kind of like having x to the 0. And 0 is an even number. So both exponents are even in that problem. Over here, if you want to use the exponents only, you look at the 2, and you have a 1. It's a mixture, so this is going to be neither. But I also want to show you that stuff about plugging in the numbers. So if I plug in 2, and then I plug in negative 2. So in this problem, if I plug in 2, square it, and then hit plus 7, so we got plus 7 times 2. This one gives me 18. And if I go back up and change it, change both of the 2's to negative 2's, the second one is negative 10. So if you're plugging in the numbers, it just gives you 2 totally different numbers. So that means that the function is neither. That's totally wrong. Hold on a second. I don't know what I'm doing. N-E-I-T-H-E-R. There we go. Okay, last one is key features. Roots. Roots are found on the x-axis. So one of them is at negative 1, 0. Here's the other one. It looks like it's at 4, 0. End behavior. The end behavior, we just want to know what direction the ends are headed. So if I look at the ends, it's down and down. That means the answer should be the same. So since they're headed down, it's going to be negative infinity for both of them. Now, domains. If you're doing a domain of a parabola, these are easy because they never change. The domains for these shapes are always negative infinity to infinity. That's something you can just memorize. If you ever see a parabola, don't care if it's facing up or down, domain is always negative infinity to infinity because it goes left forever and it goes right forever. For the range is from the lowest to the highest. Now, we already talked about the end behavior, but when we look at the lowest this goes, it goes down to negative infinity. So it goes forever down. So we have to put negative infinity for the range. And then the highest it goes, it looks like it goes just above, what is that, 1, 2, 3, 4, 5, 6. Maybe, I don't know, we're going to estimate this as like maybe 6.2. It's also a black dot, so we're going to put a bracket. Domain and range are the only things we put brackets on. Every other answer, we just use regular parentheses. The last part of this is talking about where the graph is going up and going down. So this graph heads up from this end to this end, and then it goes down from this end to this end. And when we do increase and decrease, we look at it from left to right. And what we really care about is where it changes direction. So it looks like it's changing directions here. So if I follow that down to the x-axis, it looks like it's probably about 1.5. So all of your increasing and decreasing answers, they're based off of the x-axis. So I like to stick a negative infinity over here and then a positive infinity over here, because then you already have your intervals if you do that. If you look at the, let me grab a highlighter. If you look at the left side, this is the interval for the increasing part because the graph is going up. So our increasing interval would be from negative infinity all the way to 1.5. And we never put brackets on these. Then my decreasing interval would be from here, from 1.5, all the way to infinity because the graph is headed down on that side. So our decreasing interval starts at 1.5, and then it heads to positive infinity. Hopefully this video helps. Hopefully it helps you get better scores on your test. Make sure to share it with your friends. Have them subscribe to my channel so I can get famous. But don't worry, guys, I'll never forget you. So good luck on your test.